Today's aim, Kipsters will be able to, oh, don't do that. All right, Kipsters will be able to graph all forms of equations by changing them to slope-intercept form. So again, we're going to be working on also continuing to make sure that we can identify those forms of equations, which some of you already showed me this morning that you've already forgotten the different forms of equations, which is why we're going to keep up with it. You'll notice that in our aim today, it does say that we're going to do so by changing them to slope-intercept form. There are tons of different ways to graph equations. We talked about during a previous unit how we could use plug and chug and a t-chart to graph equations. We're not going to do that anymore. We're going to make sure that the skill that we have to have and that we need to know is to be able to change them all to slope-intercept form and then use that really simple slope-intercept form to go ahead and graph our equations. So we're going to start with an equation in standard form. Considering our work says that we are going to be changing them to slope-intercept form, what is the first thing that we need to do here? If I want to change this to slope-intercept form, that. Add a negative 4x to both sides. Negative 4x plus 4x plus negative 3y equals 6 plus 4x. As I go ahead and rewrite the next step, I'm going to go ahead and commute those terms on the left-hand side so I can get that closer to that familiar y equals mx plus b form. So I've commuted my terms over here on the right side. Very close to my y equals mx plus b form, yet I don't quite have y alone. So as you get in uniform, please go ahead and tell me what the next step would be. Tell you what, I'll let you have the next one. Brianna. Divide by?
Hey.
Yeah, Brianna. My chocolate drop.
Not just 3. Not just 3.
Oh, negative 3.
Negative 3. Now, as we look at this, I want us to think really quickly because we are going to be getting to this point later. If this had been an inequality, what else would we have needed to do here? Jasmine. Yeah, flip the inequality symbol because we divided by a negative. But because we have an equation, we don't need to worry about that. Okay. Let's go ahead and do that division. That means we need to distribute that division to both parts. That's going to give me 4 over negative 3x plus 6. This is that old familiar y equals mx plus b form. Yes, Alani? No. Absolutely, it sure is. Good catch. Anybody else want to catch anything else I did wrong? Adriel? Absolutely, I didn't divide my 6 by my negative 3. That should have been a negative 2. So we're really close to y equals mx plus b form. There's one thing that we can do to help simplify this part really quickly. Brianna? Yeah, we have a negative divided by a negative, so we know that's going to be a positive 4/3 x plus negative 2. We're all set and ready for graphing. We need to identify the two different parts of this equation. One is the slope and one is the y-intercept. So really quickly, we'll write off to the side what is our slope of this line. Richard, what's the slope of this line? 4/3. And what are the coordinates of the y-intercept? Geronimo, what are the coordinates of the y-intercept? 0, negative 2. So remember, that comes straight from here. This is our slope. This is our y-intercept. All we got to do now is go down to our graph. Y-intercept, starting point, 0, negative 2. And follow our slope. Rise of 1, 2, 3, 4. Run of 1, 2, 3. Please make sure that you have it in your brain. It's rise over run. So there are still a handful of you who I think, without that reminder, might go ahead and mix those up. It's always rise over run. Whatever the top one is tells you how much to rise and how much to run. One thing you want to double check is really quickly, did we have a positive or a negative slope? Yeah, we had a positively sloped line, so we indeed should be graphing a positively sloped line. So I'm going to take my trusty straight edge, i.e. Jasmine's book. In this particular case, I'm going to draw my line straight through. Now we are going to check this really quickly, and that's going to be one of the key things that we're working on is identifying that we have drawn the correct line. And so what I'm going to do is I'm going to take that third point that I drew, and I'm going to give it its coordinates. So this is 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. It's 6, 6. So I say the point 6, 6 should be on this line. 6, 6 should be part of the solution. Thinking back to what we've done during the Do Now the past couple of days, how can I go through and check that 6, 6 should be part of the solution? Diane? No. That makes the assumption that we graphed the line correctly. So what we're trying to do is we're trying to check, make sure that we graphed this line correctly. How can I take the coordinates 6, 6 and plug it? How can I take the coordinates 6, 6 and check to see if it's part of the solution to this equation? Anybody who was just listening, I just gave it away. Jasmine, plug it in. So this is our check. Right here. We're going to plug it into the equation. So I'm going to go all the way back to the original equation, and I have 4 times 6 plus negative 3 times 6, and that's supposed to equal 6. So that's 24 plus negative 18 is equal to 6, and that's indeed 6 is equal to 6. That's our check. That does 2 things for us. Number 1, that checks to make sure that we graphed it correctly, and even further, if we missolved the equation to begin with, that would tell us that we possibly made a mistake there as well. So it's taking that third point out and plugging it in. That tells us our check. 6, 6 is part of the solution, so our line must be graphed correctly. Okay? All right. Let's look at the next one. This one is in point-slope form. You'll learn to graph things that are in point-slope form just as easily as slope-intercept form. However, our goal is to change them all to slope-intercept form before we graph. How do I change this to slope-intercept form? What's the first thing that I need to do? Cassandra. Leaf change switch is an excellent first step. Then what? After the leaf change switch, we will go ahead and distribute as Cassandra told us. It's going to give me y plus negative 4 is equal to 6x plus negative 12. And what do I need to do now, Sammy? How do I move things from one side to the other? I can't just take it and move it over. That's commuting. We can't commute across an equal sign. Yeah, we have to use inverse operations at a positive 4. 6x plus negative 12 plus 4. Y is equal to 6x plus negative 8. Slope. Slope is what, Monique? 6 over 1, so we put a 1 over that. And the y-intercept is what, Ms. Banks? What's the y-intercept of the equation? -8. So that's the point 0, -8. So I'm coming down here to 0, -8. And I'm graphing my first point. And from there, I need to follow my rise over run. I said my slope was 6 over 1, so that's a rise of 6. 1, 2, 3, 4, 5, 6, run 1. Rise of 6, 1, 2, 3, 4, 5, 6, run of 1. From there, I can take my trusty straight edge, the book that I just claimed,
Get out. It's not funny.
I can draw my line. Now, how can I go ahead and check that this is all done correctly? What did we do, Dwayne? Yeah, we'll take one of these points that we graphed, preferably the last one we graphed, and we'll plug it in. So this is the point 2, 4. So we'll plug that in to our original equation. It's y is supposed to be 4 plus -4 is equal to 6 times 2 plus -2. So remember, this is where we have to be careful. Make sure that we're following order of operations. We can actually do this easier if we do order of operations instead of doing the distribution. We can distribute here, but there's really no point. 4 plus -4 is? Okay, 4 plus -4 is 0. Over here, I want to do what's inside the parentheses first. Remember, order of operations, GEMDAS, grouping symbols first. 2 plus -2 is? 6 times 0 is? Check. Okay, that point does belong on this line. We did good. Finally, another. All right, so we want to be able to graph this equation, and we're going to do so by changing it into slope-intercept form. Tracy, first step. She wants to distribute the 6. Sounds like an excellent idea. So that's going to give me 3y plus -4 is equal to 6x plus -24. And then what? Renee? Add what? Add a positive 4 to both sides. Then what, Cassandra? Divided by 3. What's our slope? Sammy.
1e over 3. Wait, no. 2 over 1.
2 over 1. And what is our y-intercept? What is our y-intercept? I'm waiting. Dwayne is not the only person who knows this answer. What are the coordinates of our y-intercept? Alyssa. Okay, y-intercept is negative 20 over 3. So that gives us the point 0, negative 20 over 3. So the question is now, how are we going to graph this? Does anybody have any ideas how they think we could go about graphing this? Dwayne. Put it into a decimal. So that would give me 0, negative 6.6 repeating. That's a whole bunch of decimals. Now, can we use the graph that we have to graph exactly that point? No, because that's not going to graph exactly on a line. However, this is not a problem. We can estimate this. 0.6 repeating is approximately 2/3. So when we come down, and we want to come over to 0, negative 6.6, we're going to come down 1, 2, 3, 4, 5, 6, and we want to go about 2/3 of the way between 6 and 7. So I'm going to go a little bit more than half. I'm going to put my dot. My dot's not going to be directly on the line. Now, our slope is 2 over 1. So I want to go up 2. Should I end up directly on an intersection here? No, because if I go up 2, I'm going to go up to negative 5.6 repeating, negative 4.6 repeating, and over 1. So I should still end up 2/3 of the way between a point, because I had a whole number rise. Okay, so let me zoom in on that for those of you who are not quite following here. Okay? So as I rise 2, basically one rise goes from here to here, and then from here to here. As I run 1, that's not a big deal because we're already on the lines on there. Okay, I want to rise 2 more, so I rise 1, so that's to here. Oops, sorry. That's not our point. Rise 1, 2. That's still not my point. And run 1. And I can use my straight edge and draw a line. Okay.